I'm going to show you a replacement for Comfy UI and, for example, automatic and easy diffusion, and it's going to blow you guys' mind. You can actually run it on the CPU, and I'm going to test it here on my CPU, and obviously also on the GPU. So if you remember in yesterday's night stream, I explained that I found when I was doing some experimentation, I was trying to find a faster way to do local AI. So I found llama.cpp. Very impressed with it, and as you know, I think for the past 4 nights in a row, I've been tweaking my custom web UI, and I have it in almost a perfect place that makes me happy for generating code. For the code's not going to be for me, the code is going to be for you guys, just to see how good all this for testing. So it's in this particular instance going forward, I won't be able to complain about the quality of the output, because sometimes it's not the model, it's the UI. So in this case, I'll create my own UI, and that will solve that issue. It's a very simple one. It's a web UI. You can check out the previous 4 videos I've made about AI stuff. And that's one we're going to be using going forward for any chat-based AIs. Now, so when I found Llama CPP, I was so impressed, and I thought to myself, hey, is there something the equivalent for image generation and video generation? And yes, there is. So one of the most let me say prominent is called Stable-Diffusion.cpp. It's inspired by llama.cpp. So I tried it out, and I was I didn't feel like, so there was a Python binding for it. So when I tried to install the Python binding, it wanted me to install things like Clang and Clang++. I didn't feel like doing that. The reason is because those are the type of packages where you install them and I forget about them. So I was trying to figure a way where either install it in Podman, a Podman container, or just leave everything inside the Podman container, or do some type of like a virtual environment similar to the way Python does it. So I was thinking about all this, then that way I can delete the install things after. So I was thinking about all of that, but then I said, hey, before I do any of that stuff, is there a way I can test this without having to go down, as they say, that path? So luckily for me, Stable-Diffusion.cpp had pre-compiled binaries. So I tried them, and I'll show you the results. I was actually pretty impressed with the result. The speed was very slow, but because when I went to the Python, I was actually at the Python binding page on GitHub. They showed that you can actually compile it for Wacom. So I was like, because I think the author of the Stable-Diffusion.cpp, he tried to compile for, or somebody, maybe one of the contributors, they just gave up because apparently AMD, the drivers are not well, they are not in they don't fix the bugs, I guess, in a timely manner or something. So, but when I was looking through the issues, I know some people were successful. So I guess the documentation is kind of sparse, but I was able to find some documentation on how to install it. I guess they had the general information, so I followed that, and I got some hints from the issues. And then the thing I said, I still didn't want to install Clang and Clang+, no matter how performance or the faster they are, because I already have GCC and G++ already installed in the system. If you remember, I had to install the cooler controller for the sensors. I had to do the sensor, so I was like, I already had that on my system. I didn't feel like installing some other compilers, so I said, hey, I already have GCC and G++, let me use that. So I used that, and I installed Ninja. I was a little bit worried about that, but Ninja only took up like 144 kilobytes. So I was like, okay, that's not a big deal. So I installed it, and then I ran a test, and I was impressed with the test. So this tutorial is mostly going to be on the command line because, hey, why not? So what I'm hoping for is that if I speak quickly enough, I can probably get through most of the command line stuff, explaining all that, and then we can maybe get on with trying some. We'll try this one. We try the. Remember when I tried to install the this one, the WAN 2.2 text to video 14B in ComfyUI, it failed. So what I'm hoping for is that all that information that we did, that was the one that was like, I think, close to a 4-hour live stream. So I'm hoping is that all that information from that one, we can repurpose it today and get some videos done as well. So I know this one did work in ComfyUI, this WAN 2.2 at TI text image to video. So that one did work. So I'm hoping that this one works. So the reason I had problem with this 14B one instead of the 5B one was this one, I think that one of the sensors was one from 2.1. So that's probably one of the issues. And there are so many models as well. So this would be a good way to decide which models to keep and which models to get rid of. Because right now my AI partition is getting pretty full. So it's mostly just models. So even if ComfyUI does, even the Python virtual environment doesn't take up too much space, but it's mostly just models. So I'll be able to go through the models and just keep the ones which generate good pictures and everything. Okay, with that said, let me show you. There's a lot of information here to show you guys. But before I get started, quickly, be sure to subscribe, like, follow, and leave comments. And that helps the channel grow. And as I said, like for example, this when I did this live stream, it was like 4 hours. That's because it's back and forth between me and one of the viewers. So one of the viewers doesn't make sense. One of you guys was viewing. Thank you very much for that. So so that's what I'm saying. Like the live streams are pretty good because I can, it can go longer than the one in the afternoon. I have to go look up the chickens and there's some other chores, but the one at night it's more relaxed. You guys can ask me questions and it can go for much longer. All right, so let's get going here. I'm gonna leave. I'm not gonna go to these articles yet because I said I want to get the. I want to show you the other stuff first. Then we can go and check. I think this one will probably be better because this one will have a lot more information. But here, let's get started. So I have. I'm also live streaming on YouTube, BitChute, Rumble, and Odyssey. So I'm going to check if those streams are okay first. I'm going to check on BitChute, just refresh the page. And I think it's working. Yeah, it is working. I see it's a little, okay, it's spinning, that's fine. And this one is, let's see the play button. I don't know why Rumble does that as well. Okay, that's working as well. And let's go to Odyssey. Odyssey is usually slow for, I don't know why. I always have to refresh twice. I think this is it 10 minutes ago. Yeah, that's it. It takes a while to pop up. And I do not know, why does Odyssey do this to me? Come on. I have to grab it, paste it again, and press enter. Now it will work. No, I have to do it twice. Okay, just a second here. Come on, Odyssey, fix that thing. That's a bug, definitely. Okay, that's live. Okay, that's going well. And obviously YouTube is fine. Okay, so I have a whole, and also you guys are going to see this. This is my cooler control, because we actually, when we use the GPU, this temperature is going to go up. So this is my cooler control. I've been using it all day, but it never worked. I was using the CPU, so you're going to see the CPU temperatures go up when we use the CPU. Went up to like 70 something, and then I said we'll take care of this GPU here. I just put this at 50%. So I'll just put 50 for now. So then I can just hit apply when the GPU is being used. I'll show you that later. Okay, so I'll show you the links. Where is the first link? Oh, here we go. There's a lot of information here, so I think Okay, not there, not there, not there. Ah, man, where is the page? Okay, okay, there's a lot of stuff here. So let me just copy this, and I think I can actually go through it here. So I'll do this. So this application is called Stable-Diffusion.cpp, and as you can see here, this is its GitHub page. I think I put it into the I might have put a link into the description. If not, I'll create when I create when I create the article later dedicated to this. I will put the link there as well. But it's very simple. Just GitHub. You just search for Stable-Diffusion.cpp. Now, when you go in the search engines, some of them are a little bit confused because they think it's Stable Diffusion itself. No, it's not. This is I said this is inspired by llama.cpp. Okay, so as you can see here, they have a bunch of stuff for you, like for examples. They have a Docker file if you want to run it in a container, and then you have Musa system. I think this is CCL. I don't know what that one is. And then obviously the usual stuff for how to compile it. And then you can see here Stable Diffusion CPP, and that's actually pretty nice. I wonder if we can do that ourselves. And as you can see, it was released pretty recently, just less than a month ago, the latest version. See, this one supports Quen image edit, Quen. So this one supports in September of 2025. They had support for 2.1 VACE. And then you see here it supports also 2.1 and 2.2. So that's fantastic. I'm curious to see how this two will play out. We'll check it out soon, and then you can see here it's a plain C/C++ implementation of GGML working in the same way as llama.cpp. Okay, it's super lightweight and without external dependencies. That's one of the things where obviously it's going to use less resources as well because it doesn't have to load all of them. And you can see the image models it's supported. SD1 obviously, and SD2, SDXL, image edit models like the Flux, Quen, video models we just talked about, 2.1, 2.2. It also supports FotoMaker and ControlNet supporting SD 1.5, LoRa, same as Stable Diffusion. So if you notice some of this stuff, they basically they base it on Comfy UI. So the folder structure is similar to Comfy UI. So and then the supported backend, the CPU, that basically for all x86 architecture, CUDA, Vulkan, Metal, OpenCL, and this one SysCL. Okay, and then the supported weight formats, PyTorch, Checkpoint, Ceph tensors, and GGUF. Ooh, nice. And then supported platform Linux, Mac OS, Windows. You can even do it on Android via Termex. And Flash Tangent for memory usage optimization, negative prompt. And then they have the sampling method. And then for cross-platform reproducibility, you can use this RNG. And that's there's CUDA or the stable, I think stable deviation. And then for that's the GPU, obviously I can't use that because I'm using an AMD Instinct Mi60. So I expect this not to be any problem because I said before in my OBS I removed the dedicated GPU from recording the video. So if anything happens, I should still be able to record and also do the live stream without any problems like before. And then you can see here, you can download the pre-built binaries. We'll go to that in a second after this. And then you can download the model weight. So as you know, I already have this because I was using Comfy UI. So we test it with some of the ones I already have. And you can generate the simple image here. After this is the compiled one, but you can also get the pre-compiled one. So you can always tell because the one you compile yourself, it's going to be bin/SD, and obviously the one you download will just be SD. And then you see they have guides here how to do it, and the Python. There are also bindings for Golang, non-CGO and CGO, and there's C#, Python, Rust, and Flutter Dart. So when I went to, as I said before, when I went to this Python one, let's just go back here quickly. This might be an easier way for you guys to install this. You see, very simple installation. You just need Python 3.8, a C compiler, GCC or Clang, and then your Windows, obviously, and Mac OS. Mac OS Xcode. Windows, you need Visual Studio or Main W. And you just type pip install and stable-diffusion-cpp -python. Now this failed for me because when I tried to pass in some environmental variables, I was a little bit lazy. So if you look here, I was able to find my raw com and all of that. You see here, it says Clang. I should have changed this, but I was too lazy because one of the problem with Python is that it likes to introduce a whole bunch of dependencies. So I didn't feel like doing that, so that's why but I want to test it first. So as you can see, obviously this is a high-level API, so you can write everything in Python. Now, you might say, why didn't you do this? Because you're already doing it for the text one. I'll tell you why I didn't, because when I'm generating an image or a video, normally for my use case, I'll probably just generate one image or one video. So I don't need anything fancy like like generate 10 images and then take those images and scale them and then put them into a video. I don't need to do that. What I mean is that I'll probably want to see them first, is what I'm getting at. So I don't. But if you want to do it without caring too much, you can use binding like this, the Python one, as an example. Obviously, I say there are other. You have other bindings as well. So here we go. So I said for me it failed because of the I was too lazy to change the CLang to GCC. So one of the reasons I didn't want to install CLang and C++, Clang, as I said before, is because I already have I've already GCC and G++, so I didn't feel like installing more. So this one here, this one, it's an Intel. Okay, so that's an Intel. If you have an Intel GPU, that's the one. Because I've never seen this before. So that's for Intel. And obviously, you can also use Vulkan or OpenCL. OpenCL could also work, I guess, for Android devices. Arduino. There we go. Okay, so those are the bindings, and then there are some UIs already. As I said, there's Jellybox, there's Stable Diffusion GUI, there's Stable Diffusion C, CLI, and GUI, and then there's Local Diffusion, there's SD.cpp -web UI, there's Local AI, Neuro-Pixel, and then this one COBOL CPP. So if you just want an easy way to do it, you can try one of those ones. And here are the references as well, as you can see. So as you guys know, I already have one 2.2. I both have the 14B and the 5B. If you remember, the 14B did not work. So if I'm not able to get the 14B to work today, that would be perfect for me, because I think this one is taking up quite a bit of disk space, so I can get rid of this and get it down. Right now, the models, just the Comfy UI model, is taking up 160 gigs. So if I'm able to, get rid of a whole bunch of them, that'll be pretty nice. So if this works, and I said I already tested it working, I'm pretty happy with the results. Most likely will not use Comfy UI going forward. I'll just use this stable-diffusion.cpp instead. It's not because Comfy UI is bad or I used SD Next before that. No, I was just saying that having something where I can start and stop it easier for me. What I'm saying is that if you want to use the I can understand why you want to use something like Comfy UI or SD.next. So variety is good. pick whatever you want. It's good that we have different variety. I said for me, I want to squeeze every single performance out, so that's why I do that. And all right, so that's basically it. And so what I did was, you see, I went to the releases here. If you go to releases, and you can see here under releases, these are assets. You can see there's one for Windows, there's one for down, that's Mac Macs. There's the Ubuntu one, and then the rest are all Windows except for the source code. So if you see this, they basically compiled everything for you for Windows. There's CUDA here, no AVX, and then there's Vulkan. So unless your system only is OpenCL, you should be fine with one of these if you're on Windows. Now, if you're on Windows and you want to use Welcome, I'm on Linux, and I obviously want to use Welcome. I had to compile it. That's one thing that confused me, because I didn't see that, so I had to, but I mean, I did figure it out. So finally, I have to compile it. I'll show you how I did. In fact, I just finished not too long ago, just before this tutorial, this live stream. So this, if you're on Linux, even though it says Ubuntu here, you can actually, I think it's because it was compiled on Ubuntu, but you can actually download this. That's what I did, and you can extract it. You can start running right away, and I'll show you. I'll show that to you. I think, is there anything else I want to talk about? Oh, yeah. So let's. I need to stay here because I gotta check this guy out. So maybe I'll make it a little bit smaller, like right here. That's what I'll do with the window. I'll make the window a little bit smaller, like this, just so that we can see what's going on. All right. So where is the folder? Did I close the folder? Oh, it looks like I did close the folder, which is fine. I will go back to my downloads folder, and I'll show you guys what I did here. Where is... Oh, did I delete it? Oh man, oh, don't tell me I deleted it. What was the name of this? What's the name of Stable-Diffusion? Oh, don't tell me I deleted it. Hopefully it's in my junk. Let me. Oh, did I put it? Oh no, I think I put it somewhere else. Let me check my trash. No, it's not in the trash. Maybe I put it in the AI folder. Oh yeah, I did. Excuse me. I didn't expect the heater to come on. Sorry about that. Because I don't have the heat exchanger on. Yeah, I did. So I can show you guys this. So what I downloaded and I put it, you see it says SD master bin Linux Ubuntu. So I just extracted this, and then inside you see there's 1, 2, 3, 4, 5. There's 5 files. There's what do you call it? There's this. It's just a license. I did it. Yes, it's MIT license. This text file, the Stable Diffusion one as well, is also MIT license. So both of them are just licenses. And then you have the so file, that's usually a library, and then the SD. This is the executable itself. You see, it's pretty small. It's pre-compiled. Both of them take up very low space, right? And this was my output. You see, it's this little cat, and I was really impressed with this one as well. So I just used the default syntax, and I was able. So I'm gonna run it again, and just to show you how. Before, did I move? So I'm still using, because I haven't deleted Comfy UI, so I'm still using all the models from Comfy UI. So I'm gonna delete this guy, and if you see here, it's only gonna use the CPU. This is the dedicated GPU. So when the temperature goes up here, you know it's being used. If it's so, this one is going to go way up soon. So I'm going to open up a terminal. Come on. Open a console. It's fine. And you can see proof that I'm inside here. Oh, come on. Okay, I'll make it smaller. I'm going to clean this up a little bit and clear. Clear. Okay, let's zoom up just a little bit so you can see what's going on. I'll put it down here so you will see And then what you do is very simple. I hope I didn't delete all that stuff. What did I do here? Yeah, so we just type ./sd, then space -m, then the location of the model. I said I'm still using stuff in the Comfy UI, so I'm going to use the v5, so 1.5. Let's say tensors. Paste that in there. I'm going to zoom out just a little bit so you can see it. Then space -p, then space, that's for the prompt, of course, and I'm going to say lovely cat, and just press enter. So if you see, look at the CPU. The GPU is not being used at all, it's just CPU, and you can see it has 42 seeds. So it's going to take a little bit of a while, and you see the CPU temperature is already at 75%, as you can see here, the sampling. I just use all the defaults. There's no LoRa's I'm using, text to image, and and you see it's just using, you can tell here it's clearly just using RAM. Oh, let me open up the task manager on system monitor so you can see what's going on here. Put this up here so people can see. Can I just make it smaller? Okay, there we go. Okay, that's actually pretty good. Let me put it here. Yeah, you see the temperature is 80 degrees on the CPU. See, this is the reason why I do the manual fan control for the GPU. See, it's already at 80. The CPU is already at 80, right? And that already has a fan profile, right? So you can imagine that's exactly why I control the GPU manually, because I don't want the temperatures to be going up past 100. Now, when the temperatures, I think, go probably around that, it probably throttles the CPU, and you can see the CPU is working really hard here as well. So, because remember, I'm also using the CPU to, the integrated GPU to also live stream and also record the video. Okay, so we'll go down here. It's about 50% done, and you can see the memory usage. It's not using any swap, so that's very good. We'll time it. Obviously, it's a little bit unfair because I'm also using, I'm doing other stuff with it as well. Not just the open browser, but there's OBS as well. So it's probably going to be slower than it took last time, but you can see, we'll see how long it takes. Here, it's about 1/3. No, not 1/3. It's about 2/3 done. So yeah, so it's obviously very slow, but it does work. And we'll check the default dimensions of the photo. I think it's 512 by 512. So for running on the CPU, yeah, it's not. If all you have is a CPU, yeah, it's gonna be slow. Just make sure that you watch those temperatures. As you can see, I'm using the stock cooler, the Ryzen 5 5600 GT. So, you can actually see the name right here as well. So that the G stands for obviously means it has integrated graphics. So it's almost done, but you see it's slow. I mean, compared to when you use the GPU, but don't worry, we'll get to the GPU. So that's a downloaded binary, and you can see there it's sampling completed. It took 204.5 seconds. So that is what is that? That's a 21. So it's done now. So it says it generated completed it took 21 seconds. Okay, so let's round it up. 23 seconds. 21.97 seconds. 23 seconds. Okay, so it took 23 seconds to generate the image. Kind of seemed like it took longer than that, but there we go. It took 23 seconds. So clearly If you have a faster CPU, or you have more threads, cores, threads, obviously it'll go a little bit faster, but the code is actually pretty good. As you can see here with the cat, it's pretty consistent. So let's check the properties here. I believe it's 512 by 512. Yeah, it's 512 by 512. Obviously you can change the PNG file, and it's actually pretty good quality as well, as you can see. Yeah, it's actually pretty good for just for that. It's a pretty good quality picture. Sorry, I should say decent. I should say it's a decent photo. 512 by 512. If you remember when I tried to do stuff like that in Comfy UI and etc., I wasn't able to get I had to increase the resolution to get a decent photo. And that's what they keep. If you search online, they'll tell you, oh no, you need to increase, you need to have a higher resolution. No, you don't. It's like sometimes you don't want that. So this is pretty good. I could work with this. All right, so that's the CPU. So as you saw, it took 22 seconds. Now maybe if I had a CUDA and NVIDIA, I would probably stick with the pre-compiled binaries. You just download a set and you're good to go. However, for my particular use case, I think I'll leave this so when I create an article, we can do a comparison as well. So as you can see, the CPU is down and it released the memory, which is actually pretty good. So let me take this out of here, and the temperature is going down for the CPU, so that's fine. Now, so once again, that's this. You see one more. So that's the one that generated. So not bad, not bad at all. All right. Now what I'm going to do is I'm going to show you the commands I used to run to compile it. Didn't take long to compile. Compiling doesn't take too long. Before I do that, I'm hoping everything is in one place. Yeah. So what I did was I made sure I had GCC and G+. Oh, I had to install some other stuff. So I'm not sure if that will show up. Where is the stuff where I installed it? Is it here? Oh yeah, it is. Okay. I'm just scrolling and I'll show you everything. There's quite a bit of stuff like this. So everything is here. Yeah. Okay, here we go. So the first thing I did, let me actually, I have to make this a little bit bigger so you can see. So this first tab is the cooler control. I have to run it as a sudo user, so that's why this is here. That's what you're seeing here. See, it's the sensor NCT6687, and the port number is 11987. So that will come in handy pretty soon after I finish this part. So when I tried, remember I showed you the Python one. I tried to get the Python installed. But I even created a special virtual environment for that, and I wasn't happy, so I just removed it. I installed everything, then I removed it, and then as you can see, my system here. Where is AI? Yeah, AI here. So I was able to get back about 20 gigs or so. When I deleted I deleted that model, the DeepSeek R1. I deleted that one because I think we tested that yesterday. I wasn't too happy with the result, so I deleted it and I got some space back. But there's too much. You see, it's 220 gigs the total. So right now 180 is in use. 160 of that is the models, the Comfy UI models. So if I can get rid of some of them, that will be, like I said, that's the plan for tonight. All right. So to find out, so what I did is I created a folder called Stable-Diffusion.cpp, Then I checked what GCC version I had. As you can see here, I'm using Fedora 43 in case you're wondering. I just recently upgraded from Fedora 42 and the G++ version. So I didn't, like I said, when I had this, I didn't feel like installing, what do you call it? I didn't feel like installing Clang. Clang might be faster, it may make the application faster. I wasn't, like 1 second to a few milliseconds I'm not going to lose sleep over that. I'll just be happy with the result. So then I installed, because I knew you need some dev packages. I keep on forgetting, this is the thing when you use multiple distros, because I came from Debian. Debian, you see it always says rocom-dev, even though I put DNF, so it's just the way Fedora does it, or Red Hat, it's DEVEL. So they gave me that error. Then I what is it called here? So what I did was I searched. What did I put here? Where is it? Come on. Oh yeah, DNFs. Oh sorry, I forgot to zoom in. I apologize about that. So I did DNF search Rocom, and it listed all the Rocom packages. So you can see the Clang one. I said the thing is I would have to install all this. I didn't feel like it. So the one we're looking for is the development one. Where is it here? Where is these? Yeah, here, this one. Rocom said it's VEL. That's how I said Fedora and Red Hat family usually do it. So when I did that, when I found that one, I then where is it? Yeah, then I ran that command again with the fixed ones. And then this time there was some problems, most likely because there must be some new updates. So I put allow erasing, because I don't use OpenCL for anything. Let me explain to you what I mean. OpenCL was removed from Blender, so that could have been one way where if I use a Cycles engine, I could have been able to use that. But so I couldn't think of any. I don't think there's anything else. Even the only thing I could think of is perhaps maybe FFmpeg could use it to speed up some things sometimes. But I can use I think not Rocom. What do you call it? The what's the name they use for the AMD GPU on the command line in Linux? So yeah, it's hard. You can use the hardware for that, for H.264 and H.265 for encoding and decoding. For the AV1, it's only for decoding. Okay, so then I put allow erasing, and then I was able to install everything. You see, it removed this old one, and so everything did install. It's CMake, all this stuff. As you can see here, just quickly go. There's quite a few packages here. So this is why I said I didn't want to install Clang, because it will install even more packages. Even with all that, you see it says that it's going to remove one package. It was only 163 megabytes, and then it's going to install an extra gig of of stuff, right? So if I install Clang, it would be even bigger. I think it was like 20 or something. I didn't feel like doing. It's not because of space. It's just because those are the top packages I might forget about. Let me zoom out here so I can go this very quickly. So they're installing now. The download first and then installing. So there we go now. Oops, there we go. So when I install it now, you can see how much disk space is there. Where's my 29 still? Okay. Then I cloned. I cloned the repository for the Stable-Diffusion.cpp. The instructions tell you to use recursive, and I'll explain to you why you have to do that when we actually go down more. So I also put depth 1 because I don't want to clone like the entire history. I just need the top level one. That's why I put depth 1. I in the Git tutorials I did explain why you should always use depth 1 if you're cloning for something like what I'm doing here today is compiling. Otherwise you have the entire history. Now this one is probably not too old, so it might not be that big, but if you're downloading the entire history, my goodness, it will be it could get big and big and big and big. I've seen some packages, even though I have a high-speed internet connection, just take forever, and that to me that's kind of a little bit unacceptable. If I'm one of the contributors and I'll look through history, yeah, sure, but most of the time I'm not. So we cloned it, and because I put recursive, that also gets its submodules, and you see some of them here. For example, this one, GG ML. You see it got that one from this one, ggml -org, ggml.git. So it got that one. Is there another one it got? I think that was the only one. Yeah. So that's one that was a submodule that it received as well. So had I just done without this recursive, it would basically just have gotten that. Then I would have to manually. Sorry, I didn't even see that. Even right here it says submodule. It will not retrieve the submodule. You'd have to go do that manually, and that could be tedious because you wouldn't know where they are. So it's always good to put recursive, especially if you use other libraries as well. So then after that, the name was the same. I expected the name to be different, but that's fine. So what I did then is I found out I wanted to see how big the file size is, and you see just by git clone, and because I used depth, I was able to save, you see, some space, and it was only 203 megabytes. So I cd into that folder. Then I wanted to see if I had Ninja build, so I searched for it. There's a Ninja build here. It's supposed to make your it's supposed to like be more efficient for building. So I did install it, and I was pleased that it was only, you see here, it's only 400 and what is it? It's 490, is it? 481 kilobytes. So I did get it, and I downloaded it. I don't know why. Why does it say need to download 120? Oh, that's weird. I don't know what it says. But anyway, so when it's installed, it becomes okay. I got it. So because it's compressed when it downloads, and then when it installs it, it's going to be that size. Okay, that's fine. So it's pretty small. No big deal. So then after that, I created a folder called build. I cd into the build, and then I ran this command. Obviously, Rocom is installed. You guys have seen it. So it's at /user bin Rocom info, and then I ran this one. Obviously, this is the GPU we want to use. We want to use the dedicated GPU, not the integrated GPU. So how do I know this is a dedicated one? Because it's GFX 906. If it said 90C, that's the integrated one. So then after that, I just basically did a copy pasta, right? And then obviously now I had Ninja, and then you see here it says the compiler is Clang, and the C++ compiler is Clang++. So obviously it failed. Then I slapped myself and I said, oh, wait a minute. The command we ran up there was for GCC, so I just changed that. You see here the compiler is GCC, and then I use G++. Now, be careful when you do things like this, because this particular application might be specifically geared towards Clang. So be careful when you do things like this. But I said I was testing. So in my case, you see there was no issues. And then I could actually did the CMake build. And then you see there was a few little so there's a few warnings here, but usually when you build for C or C++, you normally get warnings, but that's fine. They're deprecated as long as it builds. That's the most important thing. So it did build, it finished, and honestly, this didn't take very long. I was even debating whether I should actually redo this when I'm doing this live stream, but I was like, you guys probably don't want to wait around an extra. I can't remember how long it took. Maybe 1 minute or something, maybe even less. I can't remember. It didn't take long. And then you see it's bin/sd. So after that, I did an ls, and you can see there's a bin folder here. There's a build Ninja. So we just and then there's some examples for you in ggml and some third-party stuff. So then the lib Stable-Diffusion lib stable-diffusion.a. So if you don't know what this is similar to the so file you saw earlier. Yeah, they usually just rename them. They usually get renamed to so. Or you can specify the name you want, but usually by default in C, I guess C++ as well, it just puts an A or just appends something there. So that's it. So this is the actual library here. So with that said, I was ready to test it out. So as you can see, then I ran bin/sd space -m, and then the path to the actual model. As you can see, it's still using the Coffee UI models, and then I used FP16. If you remember, we talked about this. If you remember, yeah, just yesterday when we were reviewing how was it yesterday we did, or the day before? I can't remember now. I think it was the day before. I was explaining how you know how to pick the better quality models. So that's how you do that, and then the prompt was a lovely cut. Sorry, a lovely cat. Okay, and you can see here it ran this, and this time it was looking for the CUDA stuff. It says CUDA no, CUDA no. Oh, it found 2 ROCm devices. So the 0, that's the dedicated one. You see it says GFX 906, but it also found this one. This is the integrated one. You see it's GFX 90C. So so that one I didn't even pay attention to this. I don't know. I know it used the dedicated one, and here's how I know it did. And you can see this is F16. So if you remember, the higher the number up there, the better the quality. So I could have probably used if I could find an F. I think when I was doing this particular tutorial for this Stable Diffusion, not Stable Diffusion, 114B model, I couldn't find an F8, so there's only 16, which is fine. So yeah, so here we go, and we can tell that it used the. You see here it says VRAM. Compare that to when I ran it on the. Do I still have that window open by any chance? Is it this one here? Yes. So if we compare to this one, I'm going to zoom out a little bit. You see this one wasn't using any VRAM. If we scroll up, yeah, you see here it says, let me make this bigger so you guys can see it. You see here it says VRAM 0. So this one, it just used the RAM. It didn't use the VRAM at all. That's why it was slow. You see, just use RAM. None of this is in VRAM. You see even the control net, VRAM, B, mid, RAM. So this one didn't use any RAM at all. And this one, you see, it does use the VRAM. Very little VRAM. In fact, I think it just went up to 50 or 52, but I didn't want to take any chances, so I did put up the fan. I had the fan running, and you see it took much less time. So you can see it took milliseconds here and here, and then it says generating Latin completed, taking 8.9. This is not true. It didn't take 8 seconds. Trust me. It actually took 1 second. And decode first stage completed 1.3 seconds. It says generate image completed in 10.68 seconds. It didn't take 10.6. Said it was really fast. And we're gonna do another one right here for you guys, just to prove to you that it doesn't take. Unless, okay, you know what? Let me actually time it. I'm gonna open up the clock here so we can see how many seconds it takes. I'm just going to press the up button. Oh, let me show you the quality first, and I'll delete this image. So this is in build. So this is the cat. You see, I think it's actually even better than the other one. Let's compare it to this one here. Right? Yeah, this one here was by the CPU, and this one here was by the GPU. And I think the GPU is actually better. Right? Yeah, the GPU is definitely better. I didn't even realize that. I think there's some artifacts here. So the GPU, oh yeah, the GPU one is better. You can see the whiskers. So the GPU one is better. However, I'm going to delete this one here, and we're going to compare it to the CPU one. So I'll put the CPU one here for now, and I'm going to delete this one. I'm just going to press the up key so it regenerates the image. So I'm going to click here and I'm going to hit start as well. So press enter. That's the same thing, bin/sd space -m, and then space the model you want to use, then space -p space, then in double quotes I put a lovely cat. That's it. So I'm going to hit enter now and start. So I want to see how long that takes. Okay, I was wrong. 2 seconds, 3 seconds, 5 seconds, 8 seconds, 9 seconds. What's going on? 10 seconds. What is it doing? Jeez. I must be dreaming. It didn't take that long before. Wow. Okay, it's done. It says 10.61 seconds. What the? Okay, so all right. So there you go. Okay. Despite everything, so obviously, oh, I didn't even check the temperature. You see, I didn't even see this. You see, I forgot even to run the CP. I forgot to run this as well. You see, it's 48 degrees. So when you're creating images, at least small size images, it doesn't really make a difference. I don't even bother running the GPU because I think the GPU just goes up to about 50, then it goes right back down because it's so fast. So there we go. So yeah, so you see the temperature is going down. I think at it's around in summer this is about where it is, 47, but I think it'll go down a little bit. Yeah, I think it's about 43 or so on idle. So that's perfectly fine. All right, so let's compare the this is the one. Oh, it's slightly different than before, and there we go. Yeah, so definitely the oh, what is this? Oh, okay, I thought that was another fact, but yeah, so definitely the GPU generates way better images than the CPU, which actually surprised me because I thought the CPU would be more accurate, but there we go. Unless you guys see something which I can't see, but yeah, definitely. You know what? I'm gonna try. Okay, so we're not gonna use the CPU. I'm gonna try another. So there's so many settings, and I mean there's so many settings. Is this the one here? Confused now. Oh no, this is not what I want. So let me actually move this out of the way. That's not the one I want. This is the one I want. Yeah, this is the one I want. So this is still way faster than when I used Comfy UI. So there's so many options. There are a couple ways you can get the options. In fact, the latest options are from if you type bin slash what is it, SD, and then you do something like help. Yeah, here we go. I want to zoom out just a little bit so we can see. Yeah, there we go. So you see there are way more options than the ones I actually documented in the official site. So you can see here, you can how to load the model, just -m or -- model. And remember, so if you do have an AMD GPU and you want to use Wacom, you will need to compile it yourself. Unless you're in Windows. Windows, they have like Vulkan. You could probably try Vulkan. So yeah, so here you can see you can change the output. I'm looking for size. Yeah, here we go. Height. I can do the height and I can do the width. So I'm going to do that in a second. And then yeah, so let's do something that is I'm going to put up here a lovely cut. Then I'll put, I think it was -h. Yeah, I think it was -h. -h, was it an integer? It didn't specify. Just a second here. Am I crazy? What is the height? FPS, you can also do FPS. Oh, a capital H. Oh, here we go. I almost made a mistake. So it's capital H and then the default. Okay, so is it a space? in pixel space. Okay, so so I just leave a space. Okay, so what I do is a capital H, and let's make it 720, and then capital W, and make that 1280. Okay, so I'm gonna hit enter. Where is, man, I really, okay, so I'm gonna hit that. I'm gonna check the temperatures here, and then I'll be ready if we're going to see the temperatures going up. Okay, this, I hear something, but is it not using the GPU? What's going on here? Okay, maybe did I make a mistake? Oh, they say it failed? Oh, yeah, it failed. It says must be a multiples of 64. Oh, that's for the SD one. You got, so, oh, this is the multiples of 64. So, what is that? 64, was it 1280? 1280 does work. That's a multiple of 64. So 720 does not work. I have to work on that one. So 720 divided by 64. Okay, that has to be a whole number. So which one would, is it 7? Let's see. What was it again? 720. So let's try 11. 64 times 11. Okay, 704. 704 works. Okay, I'll try that one. So the height has to be 704. That should be the multiple. Okay, let's see the temperature go up here. Yeah, the temperature. Okay, no. Oh, it's working. Okay, you see the temperature is going up there. I'm just gonna watch this, and if it goes to 60, I'm gonna dump this. Okay, there we go. I don't want to take any chances. So I've turned on the fan. So you can definitely tell that it's using the GPU, because this temperature here went up to, you see, it's now in the, it's almost 70. And yeah, there we go. And this is exactly why I can't trust the fan profile. So it's done, it's finished. So I can actually turn this down. I'll turn this down back to 2%. Although the temperature is high, it will eventually go back down. So I can turn it off. So it finished here. Let's see, it says it took 42 seconds. So let's check out what the image looks like. Here we go. So it's close enough to 16 by 9. That is odd. Okay, I can. Is that an artifact? Okay, that is weird. Okay, that is weird. I guess it likes squares. Oh no, maybe not. Oh, maybe not. Maybe that's one cat and this is another cat. So, okay. Could this be a tail? Alright, but anyway, it's the resolution is actually pretty good. I'm actually surprised. Okay, not bad. Alright. So I'm not sure what to do next. Should I try some video stuff? Yeah, let's do some video stuff. Okay, so I haven't run any videos for a while, so I'm going to see. I probably have to look at the documentation for that one. So let's go back. So you guys already explained this. So let's go back to the, is it code, I guess? And I think the examples of running when details merged. Okay, so yeah, video models. So let's go check this out. Oh, I should have written. So I want 2.2. This guy here, 2.2. Yeah. So I already got this, and so as you guys know, that's the 5B. Yeah, the 5B T. Yeah, that's the one. I got this one. So download them, and then here's an example. I want the 2. Is this the one? 2.2 AB. I'm guessing this is text to image. No, this one. Text TIV5B. Yeah, the naming conventions are kind of. So I also have this one as well, and I have this one. So I'm going to. This might actually work just the way it is, because it's not weird, because it knows the folder path as well to the conf UI. Let me actually check this one out. This might actually work. I'm just gonna paste it. Do I have a text editor for you guys here? No, I don't. Okay, so I'll paste it somewhere here. I'll just do a full path to the. It's the same thing. So I think I'll just do a, what do you call it? I'll do a an absolute path. So I'll just put /mount/AI/ and then I'll do the same thing for the V2 sensors. So as I said before, it uses the same folder structure as conf UI basically. So that makes it really easy to, because I already have conf UI. So I'll show you my command. I'm just fixing it up here a little bit. You can see, I believe everything should be. Anything else? A lovely cat. Okay, there we go. Okay. So, and then this should be. Okay. This is Windows. You see, it says bin release SD. I don't have that. Mine is simply just bin/SD. Because I'm on Linux, so I'm just gonna copy that, and then this is what I'm TUV scale video 33 frames. Okay, so if you want to look at what that says, I think this is easier here. That's a negative prompt. There's Chinese characters. The width is 480. The height is so it's gonna be a vertical one, 832, and that's offload to CPU. Ooh, I don't want offload to CPU because I just want it to run to the GPU. Oh no, it only offload to the CPU if there's not enough. So I believe I have enough VRAM, so I don't have to worry about this. And video frames are 33. I don't see FPS here. Let's see. I guess it doesn't matter. We can check it out. So I'm going to copy. All I did was all I've done is I've copied this, and I have just changed the paths. I made them absolute paths, because remember I created a folder called Stable-Diffusion.cpp. Then when I cloned it, it created another one as well. So in my particular case, I would have to put another .. for it to work, and I didn't want to do that. I just realized this convention is also Windows. Windows does that. I'm on Linux. I need to change all of those as well. So yeah, I need to change those as well. They don't work on Linux. Linux is / not /. Windows does the /. So I need to change that. Okay. flash, and there's one more. Okay, got it. Make sure I save that. Alright, so I'm going to run this. This one I'm 100% sure I'll need the GPU. So down here, I'm going to paste my command. I said I just changed it up. You see, first of all, I'm using bin/sd, not with the .exe. That's a Windows thing only. And then the other stuff I did, you see, /mount. I just had coded the path because otherwise I would not put // and then for that command it was using backslash. I just changed it to forward slashes, and that should be it. So I should press enter using where is my fan? So the temperature there, I was a little, let me put this to 50. Be ready to go here. It's using the CPU. Come on, when's it gonna use the GPU? Oh, don't tell me it's using the CPU for everything. Come on. It's not using the GPU. Oh, there we go. It's using the GPU. There we go. So I don't take any chances. I put this up here. All right. So let's go check out the command line, and you can see here. Now I know this is gonna work because it's a 5B. Because I also run this in ComfyUI. So this shouldn't be a problem. Oh, let's see how much RAM it's using. Okay, right here you see it says VAE. RAM is about 1.4, and then VRAM here. Oh, there you go. 10. It's using 10 here. That's actually pretty. Oh, 7. It says then 7. I'm confused. What does this mean? VRAM 17 meg. I don't know what that means. That's actually pretty small. We should use more. Okay, whatever. Yeah, I should probably take away that because I wanted to use the CPU. It should be using just the GPU more. But let's see how long this takes. And here it's using. This is 9 gigs if I'm correct. Yeah, it's using 9 gigs here for the diffusion model. VRAM. That's good. Okay, I'm okay with that. And reallocating buffer, Wacom, that's pretty good. You guys can see how much memory it's using as well. So it's using a little bit of swap, but that's perfectly fine, and the CPUs are not being used heavily. There we go. Is it completed? Yeah, it's completed because the memory has been released here. So let's go check out the GPU here. Temperature is still pretty high here, so is it maybe not finished? The temperature is still pretty high there, it's not going down. Sampling completed, so I guess it hasn't released it yet. Okay, so I guess we just have to wait. Oh, look at that. It used 21 gigs of VRAM. Okay, there we go. Now it's finished. It output as an AVI. Wow, I haven't heard of that one. Oh no, it's AV1. No, it's AVI. Wow, MJPEG. Oh wow, that takes me back. Okay, so here's the video. Let's actually see if there's something here before I okay, I don't see anything there. Let's see the properties. So So it's 2 seconds. It's a JPEG. JPEG. What? I think it means MJPEG. And it was 16 frames per second. It's 4, so it's a tall one, but yeah, okay. Maybe I'm okay, but I don't know what happened there. I really don't know what happened there. So whoa. That model, when I ran it in Coffee UI, it was perfectly fine, and I don't think I damaged it. So I'm just surprised. This is wow, MJPEG. Wow. Oh, you know what? Let me see if is it FF Play? I think it is FF Play. Maybe something's wrong with MPV. So I'll try output here. Output.avi. No, it's the same. Okay, so a deprecated pixel format used. Make sure you did not outset. So I don't know, maybe it's the weird format that I'm not able to view properly, but there we go. So yeah, that was a weird one. Okay, let me stop this and see if we can generate a better one. Go back 2% here. Okay, as you can see, the temperature even went way below the idle one. So yeah, okay, so let me try another one. Obviously I can tweak this. I know this one works because this one, the 5B, did generate some videos when I did Comfy UI. Alright, so I also got this guy here, which is the 2.2 text to B with 14B. So I got this one as well. So I can let's see. The viewer told me I should stick to 2.1. 2.1 ones. So I mean, now I can I no longer need configure, so I can probably throw around with that much faster on the command line. And as you saw, instead of waiting for several minutes, actually, how long did that one take? Although the video is not very good, how long did this one take? What time did it say it took? 876 seconds. What is that? 3 minutes? Yeah, just under 3 minutes. So that's not bad. Yeah, but I'm blown away that it used that format. I'm like, wow, okay, that's a weird format. That is a super weird format. You can see it did use a ROCOM. So that's basically what I wanted to show you guys here, and it used the proper model using flash attention in this. So I can probably fool around with some of these settings to get it to work. Now I'm curious to try this one, this 14B model. If you notice, the RAM was around 20 something, so there was still a little bit of spare. This one is going to be really pushing it, but that's what I'm here for. So I'm gonna try this one as well. And you can see the weights and stuff. It's FP16. Remember, that's always the higher quality one as well. And here we go. So unspecified video gen. So yeah, this was a command I ran in case you want to see it. Offload to CPU. Offload to CPU means that if it's running out of RAM, it will just offload to the CPU instead. So that's if you have a low spec GPU, or we don't even have a GPU. Obviously, it's going to take way longer than, for me it took what, 3 minutes. You may be sitting around for 20 minutes or more. Okay, so I said I can. One of the problems with this type of stuff is, I said I'll repeat again, is that they were meant to run on, say, Intel as in CPU and NVIDIA GPUs. So because I have an AMD complete system, the AMD CPU and AMD GPU, I will probably need to finagle some of the settings, but I should be, I should be able to get it, because in Comfy UI I was able. So what I'm saying is that I can probably load up Comfy UI, grab the template, and grab all those settings, and I can probably get it to work. So that's what I'll do. So it was smart of me not to get rid of Comfy UI yet, because I remember I did get some good results from Comfy UI. So that's why I said I wanted to keep Comfy UI around for a little longer until I perfect it. So I'm going to be spending the majority of my time now using this, because it's pre-compiled perfectly for my system, and as you can see, I can get results much faster. I am very pleased. I'm very pleased with it, and you guys can get started as well. It's very simple. Just download the binary, and you can it's as I say, you can get started right away. Now, especially if you have an NVIDIA GPU, you can get started. Even if you don't have one, you can just run it on the CPU to see. And I said the results are pretty good just out of the box. You can download the models. You see, I always use the GGUF. Those are highly optimized. And just make sure for your system you get the highest number of Q. You see this one, it says Q8. So the higher the quantization, the faster it will be. Obviously, it's going to use more resources, but you generate your images faster. The ones which are highly compressed, they will take a long time, right? And the quality won't be as good. So you're better off just waiting a little bit longer for better results than getting a faster result, but the quality is not good, because you could run it over and over and over again before you get something decent. So just wait for it. All right, now with that said, I'm going to try this 2.2. I'm glutton for punishment, so I'm going to try this one as well, because I did download this one. So what I'm getting at is that if this one doesn't work, I want to delete it, so I save up even more space. And I said I have a whole bunch of models. I do want to get rid of them. So that's the plan. I remember the viewer also told me I shouldn't use LTX, but the LTX video is actually the best video so far, right? So why would I get rid of it? All right, so this one 480 by 832, that is actually not bad. I mean, it has enough height. The width is big enough. That should have given me something. I don't know why it it just gave me a bunch of colors. That was super weird. Okay, so let's go here, and I said I have this model, the 2.2 TUV14B, which is this one, and I think I might have a LoRa as well. 14B, no, that's 2.1. 2.2 VAE, or VAE is only for the 5B model. Okay, that's fine. Yeah. So let me try this one here. I believe I also the LoRa was for the 2.1, if I remember correctly. So I'll just copy this one here and do the same thing as before. Yeah. So it's gonna be bin SD. Okay, so I should actually, yeah, you know what, I'll show you what I'm doing. No, I can't do, oh yeah, okay, let me open up the num text editor so you can see what I'm doing here. You guys remember this? Okay, we don't need that, so I'll just get rid of it. So what I'm doing is I changed it. This used to say whatever sd.exe, so I changed that. So what I'm trying to do is here, I'll change this. I'm gonna use a full path instead. So it's usually, slash mount slash AI slash, and then you see in Linux or Unix we use a /. Windows they use the backslash. So I'm gonna replace all these backslashes. Make sure I don't do anything too stupid here. You know what? I think I'll just do models and diffusion models. Okay, I think that we can do this one here. So I'll replace all of this. Control, is it H? Replace or R? There we go. Copy that. Paste it here, and that should be a slash. That should be a slash. Slash. Replace. So those all are fine. There should be more right here as well. VAEs. Yeah, this one's also need to be replaced. Copy that. // so backslash. And here as well, the text encoders. Make it a /. Replace all of those. Okay, and I think one more. Okay. Oh, that's it. LoRa's Raptor. Oh yeah, Rolla. This one's the last one, the LoRa's. Do I have to pick a LoRa? Oh, it will just grab them by default. Okay, I guess it'll grab them by default. So copy this command. And okay. Okay, okay, that's the one I had. Okay, so I'm gonna run this command now. Where is it? This one? Yes, is that right? Yeah, yes, here. We just paste it in here. Okay, oops, where am I? Go here, check the temperature. Yeah, the temperature is already going up. Oh no, we just went to the default one. So I'm just prepared here to go. Oh, okay, something went wrong. What happened? It failed. It didn't find this model. Okay. Oh, I made a mistake. I removed one of the slashes here. Oh, I messed up here. I thought I fixed the text encoders. Oh, I did not. Oh, I thought I did. Okay, thought I did. Oh, I forgot to hit replace. Why is that not replacing that? Okay, I don't know why that's not replacing it. Okay, doesn't matter. Oops, I want to save it. Anything else here? Okay, I think that's good. Check the GPU. CPU is going up, so that's good. Wait for the GPU to start going up. Oh, another problem. Okay, what mistake did I make here? It says get SD version from file failed. Oh, what other mistake did I do here? Unknown format. Did I not get the text encoder, or did I make a mistake here? Texting folder. Okay, this. Oh, it's oh, there's a bunch of unknowns. Let's see here. It says the model failed. Okay, it didn't find the model, and couldn't find. I do remember getting this, so let's check that out. This is the folder. Let's go to our AI folder here. We go to Comfy UI. I'm going to put it up here so we can. I'll put this as a keep on top so we can see what's going on, always on top. Okay, so the first one here is we go to the models folder. Models. And then diffusion models. And then 2.2 T. Okay, here it's a spelling. It's the problem is the spelling. It's using this low noise one. So the problem is this. This is what it's supposed to use. I guess it's just what do you call it? Yeah. So I couldn't find it. So I just need to replace this one. I'm guessing it's the same thing with the high noise. Yeah, I couldn't find the high noise as well. So I'll fix those two. And then also the text encoder. Okay, so this I just need to replace this guy here. So I'll just copy it as it is. This is the low noise. Where's low noise? Low noise, low noise. Okay, so oops. Oh, come on. Go here. It's high noise. Where is low noise? High noise, high noise. High noise. Oh, low noise. There we go. So that's a low noise one. So I grab. Oh wait, that doesn't make any sense. That's not what I want. It's the sense. It's the sensors. GF. That's it. What the? Man, this thing is hard to read. What in the world? Loading from modern diffusion. Am I crazy? I don't see it here. Oh, here we go. No, but it's okay. What in the world? Why does it have a different name than the one I'm using? Okay, it doesn't matter. I'm going to change it so okay, so that's the low noise scaled dot save sensors, and then this is the high one. Okay, copy that. And anything else? Oh yeah, the text encoders as well. Okay, so we have to go to the models and text encoders. And which one does it want? FP8. So which one did you want here? It wants a Q8. So this Is B16 or this one? Okay, I'm gonna use this one. And where is the section code? This one here. Okay, there we go. Try this. Oops. Paste. Let's see if we can go back to here. Check the temperature. Okay, something's happened. I can hear the temperature is going up for the CPU, not the GPU yet. No, it's going down. Is that good or bad? I'm not sure. Okay, I'm gonna see what's going on. Oh, okay. Okay, so that didn't work. Alright, so okay, so that one didn't work. Okay, most likely because what did it say here? Answered no. Was he waiting for me to answer something? FP waits and stable diffusion, GB auto loading, debug info from. It looks like it did. All right, so I will need to fool around with this to get it to obviously. Okay, so I will have to. I guess I have to follow the instructions. I don't feel like doing it right now, but I said like at least I got it to work, and I'm happy with that. So I will fool around with this until I get a decent. I'll check. I'll check to see. I'm surprised the text image to video did not work. That just surprised me. But I said yeah. So I'll be able to. I'll be able to run it. Maybe I have to tweak it a little bit, or I can just delete most of that stuff. So that's what I wanted to make sure that if I delete, which models to delete and which ones to keep. So I will. I'll continue doing this, and maybe by tomorrow, this will be resolved. So. I still like this method because it's much better. It uses less resources, even though I had to install a whole bunch of stuff to get it compiled. But I'm pretty happy with it because it's suited to my system, and that's what I wanted. I didn't want a generic thing. I compiled it, so it should work perfectly just for my particular system. Now, what you're seeing here, this is not a bug. Obviously, I was trying to use what I have. I obviously just have to go get some GGUF models and just follow the instructions, and I can let you guys know. So, I'll probably download that. Maybe in tomorrow's tutorial we can do it, and we can continue this one. I'm very pleased with this so far. The image quality is really good, even for a low spec, and you can also run it on the CPU as well. So there you go. All right, so let's finish up here. Yeah, there's a bunch of stuff here going on. Discard that. So I was able to run this, the 2.2 text image to video. Obviously the results were I don't know how you call that, but video was produced. This one I'm not, because I'm missing obviously the ones that I guess from the example, but I said that's why I'm here. I can run different I can run different prompts and try different things. So the image I'm really impressed with. I might actually continue doing that just to, before I finish this up. What time? How long has this been going on? Might as well go for a little bit. That's fine. Maybe I'll keep that for the next time. I think this has been long. This has gone on long enough. So I'm not gonna install the Python binding, as I said, because normally when I do things like this for an image, it's a single image. Video, I'm not there yet. So because I want to test it out and make sure the video is fine before I'm comfortable giving it more prompts. I just want to get the video to see where open source AI models are in creating the video. For the images, yeah, very good. The only problem with the images, there's still a problem with text, but that's also a problem with the more proprietary ones. They still have problems with text. But you can always add your own text. Okay, so so let's finish this up. So I'm going to pick this one because that's the one that actually got some type of video. So let's go down here. So if you want to learn Python, I'm sorry, the heater just came on again. I guess it must have dropped below 15 degrees Celsius. So if you want to learn Python, you can check out my resources. I have a book called Learning Python, and it's available on Amazon. It's designed for beginners and will guide you through step by step through the basics of Python programming. I also have an online course. It's also called Learning Python. It's available on ujamboshop.com. Offers a comprehensive curriculum that covers essential Python concepts and practical applications. Last year in 2024, I did a lot of tutorials. I used the web ID for that course, so you can check that out on all the channels. I believe I was uploading. Definitely it's on YouTube. I'm not sure about Rumble, BitChute, and Odyssey. I think they are there as well. And then the links are in the description, by the way. And then if you want one-on-one Python tutorials, I can guide you with personalized the tutorials. I offer one-on-one online Python tutorials. You can learn at your own pace. You can contact me on ujambo.com/contact to schedule a session. And if you need help with the 2.2 text, image to video 5B installation, if you want installation or migrate from that model, I'm available to assist you with that. I can walk you through the process to set it up for you. Get in touch with me at ujamboservices.com/contact. So now, as you saw today, literally today is my first time using this Stable-Diffusion.cpp. I like it so far because I can see what's going on. For example, as you see this error that happened there, I can you guys saw what I did wrong. So it's not a it's not a mystery. So I also like that I can generate images much faster than I did in Comfy UI, because it's obviously C++. It's going to be way faster than using Python and then a web UI. And one thing I like about this as well is when it finishes or when something goes wrong, it doesn't have any zombie processes. I like that as well. And you could just put on the command line, you could just quit or close the terminal, unlike the some other clients. And I like that as well. So I'm going to stick to this for a little while, and I think the only thing I'll do with my web UI is just for chatting. So this stuff like this, unless you guys want me to create a web UI, but there's so many UIs. But I'm saying stuff like this. I think the command line is perfectly fine with me. I can even shave off maybe a second or some, which makes a difference. So I'm happy with that. All right. So I think So I have. I forgot. Quick reminder: I do a live stream every day at 2 p.m. Eastern. You visit ojambo.com. You go to the watch menu, then the live sub menu, and then you can see topics for upcoming tutorials. and they always did it at 2 p.m. Eastern. So for example, you can see what we're doing tomorrow, the day after, and the day after, and the day after that. And see, we do have another AI thing coming up pretty soon. That's when I use the my custom web UI here in about 3 days time. Okay, and also be sure to subscribe, like, follow, and leave comments. It helps the channel grow. And I said, like, a lot of stuff I learned from Comfy UI was because of a viewer that was in that 4-hour live stream. So I did learn quite a bit, and that's why I'm even more comfortable leaving Comfy UI and going to something that's more low level, which is this Stable-Diffusion.cpp. And I compiled it all by myself today. Obviously, I know how to compile things, but yeah. So because when you, at least on Linux, and also I believe, yeah, and also Windows, if you want Wacom support, you have to compile it yourself. They do have Vulkan and OpenCL, but as you saw, that's not for Linux, that's for Windows if you get the proper binary for that. And obviously if you have an NVIDIA, CUDA's built in, so you're lucky there. Alright, so I also have 3 other resources I want to tell you about, so recommended resources. So if I live in a rural area where the internet and the cellular service is non-existent, so I use SpaceX Starlink, the residential service. It gives me high-speed internet. For example, right now I'm live streaming to YouTube, Odyssey, BitChute, and Rumble at the same time. I'm using FFmpeg for that. It's high speed, and I also use it for my phone. I use Wi-Fi calling, so people are able to call, text me, or send MMS messages, and I don't have to pay any roaming fees. So I remember when I first moved here, I was paying roaming fees even though the service was very sporadic. So yeah, so that's good. So if you do use my referral link, I'll get 1 month free, and you will get a discount. It's the amount of the discount or the type of discount and its duration is based on your geographical location, but you do get a discount. And then I also I have this affiliate link for this. It's the Honeywell HeatBud personal ceramic heater. It's available on Amazon. That's for my affiliate link. It has 2 settings, high and low. Oh, come on. Wait, come on. Oh, jeez. Okay, there we go, high and low. And the low one is 170 watts. The high is 250 watts. So when I first moved here, in winter, I was paying $350 a month for propane, which is ridiculous. And that was a mild winter, by the way, okay, where I only shoveled snow 2 or 3 times. Last winter was more harsh, where I was actually going out every day, 2 to 3 times a day, and my neighbor's grandson was actually coming over with a tractor or a backhoe to move snow. And still, I still had to go out because there was so much snow. Snow was always up to my knee. I still had to go out to look after the chicken. So the point is, I determined to save on propane costs last winter, and the highest I paid was $250. I think that was in February, which is the coldest month. So I saved $100 for just that month. So you can imagine that's because of this guy here. So what I did was during the day when I'm working, I left the temperature at 16 degrees. I think 16 or 16.5. That's the default setting, because it's meant to be like, it goes up to 20 degrees for I think an hour in the morning. That's when you're supposed to have breakfast and then go to work, school, etc. And then it comes on at 5 or 5:30 when everybody's back home. You have dinner and whatever, and I think it switches off at 9:30 or something like that when people go to bed. So clearly, because I work from home, I can't leave the temperature up at 20 degrees all the time. I'll be paying like what, $500-600 a month, which is preposterous. So I always wanted electric heating, but they told me propane is better, which is clearly not. As a backup, sure, but as your primary heating source, no. And unless it's extremely cheap, so it's not cheap here. So I got this little guy. I saw a YouTube video. So I got this little guy, and I've been pretty impressed with it. For example, I just turned on the heater on November 1. All of October it was off. I was able to use this guy if I need a little something, I just put it on the low setting, and put it on for just a few minutes and then switch it off. So in an hour it might be on maybe once or twice. So it saved me a lot. Now I'm working on. I wrote the article. I'm working on the. I don't know what the format of the video will be. So once that's up, I'll put it up, and it's all up. So I've had this for over a year. So it'll be a 1-year post unboxing review. So look out for that one. That should be coming up pretty soon. I'm hoping to have it up this week. Okay. So I have my affiliate link there. If you want to get one, they're available on Amazon. And finally, also on Amazon, I have this. It's the Algorithmic Serpent. It's a novelette. As you can see there, it's by me, Eduardo Jumbo. It's about a scientist who creates an AI system and loses his mind. So he has to regain control of both his mind and the AI system. This is the back here. So as you can see, this is the paperback version. Lots of pages there. And there's also an ebook version. The ebook version is free if you have Kindle Unlimited. So I made both of them as affordable as possible. There's just basically cost. The vast majority of the cost is, for example, for printing this, and then for the ebook, it's for the storage costs. So get it if you can, and let me know what you think, because I like writing, and this is my first non-programming book. Let me know what you think. I welcome your feedback, good or bad, because I said I want to improve. That's how you improve. Okay, and of course, if you go down, I also have my bio there. You can have a link to the bookshop on Amazon, and then if you need help, to my jumboservices.com site, and then the Jumbo shop for the online courses. So it's all there. Or you can go to any article. This bio will be there, and also this affiliate links and referral links as well. I might start putting those in the description, I guess, in case some people can't go to the website. I'm supposed to start doing it this month. I think I will start probably next week doing that. Okay, so with that said, I'm gonna check the live chat to see if there's any chat requests. I'm gonna start with Odyssey. I don't see any, so that's perfectly fine. I go to BitChute. I don't see any there. That's okay. Rumble. Oh, Rumble. Somebody. Sorry, I missed you. Purple. By the way, Obama Jones says he wants to talk to you right now. He also streams on Rumble too. Oh, okay, perfect. Okay, hello. I don't know. Okay, hello, Obama John. Okay, hello, Purple. Oops. Hello. Let's see. Hello, Purple. By the way, thanks for the chat. I will look out for Alabama. How do you spell Alabama John? Okay, so Alabama John. Oh, he. Okay, so I don't know how to find. Let me see if Alabama John is there right now. Alabama John. There we go, Alabama John. Okay, so I'll say hello to you. Is he live as well? Okay, it's Alabama John. Okay. Oh, he's live. Okay, so there we go. I'm gonna join Alabama John. Okay, I'm gonna say hello to you.
You could be winning too. I followed you. I gotta follow you.
Hello.
See, that's the mindset. We're not trying to be rude.
Alabama John.
Chat, you trying to be rude? Is anyone in my chat rude?
I am live.
But they're not. They're
Okay.
both. All right?
Okay, so I've sent something to Alabama John. I'm live.
We'll figure it out.
All right.
We can all win together.
All right. So.
We can win together.
Okay, I'm gonna mute this a little bit because I'm watching out Alabama John is playing some music. So I don't want to get in trouble for that. All right. So what else? Where am I? Okay, so let's go to YouTube. YouTube, there's no live chat there. All right, so as I said, I'm gonna end this. Be sure to subscribe, like, follow, and leave comments. As I said before, it helps the channel grow. So I'm gonna stop this, and we can continue tomorrow. Hopefully we can actually generate some awesome videos. We can already generate photos, no problem. All right, so all right, bye now, good night. See you guys tomorrow in the next one.